welcome to this channel, Dr.ARM's chemistry. Friends, we were discussing the organometallic compounds, in which the point of interesting is that the organometallic compounds have wider range of importance as catalysts, additives, etc., or as reagents. We have seen last time some part of the organometallic compounds as reagents, and remaining part of this will be discussed today, used as reagents. So here organometallic compounds as reagents. So in that we have seen few others organic compounds like cadmium, lithium, etc. And today we will see the organoiron compounds. Organoiron compounds. Example, that is tricarbonyl iron. So this is important organometallic compound which is used as a dyne protecting system for protecting the 1,3 dyne system. Because of this, the reactions are allowed to take place at remote center, and this is called a stereodirecting agent. This group, this organometallic compound acts as a stereodirecting group for this 1,3 dyne system, which allows the reaction to take place at remote center. So this we explain in the reaction. Here the acyclic dyne tricarbonyl. So we will see the reaction and then we will explain. So if we take this dyne system, like this, and this is protected by using the tricarbonyl iron. So this protects this 1,3 dyne system, and it allows the reaction to take place at this carbon. So if we take this example of butadiene-6 reaction of this with butadiene-6 and MeOH, it carries out so this is the dyne system, and it carries out the reaction at this center. So we get a product like this. So this dyne system remains intact. And here we get this addition of this BONE twice. Means without disturbing this dyne system, because of this protecting group episode 3, the reaction is allowed to take place at this point. So if we number this like this, 4, 5, 6 and 7. So the reaction takes place at this 6. Again if we carry out another reaction, that is MeCO Cl A using Al3L3 as the catalyst, the reaction takes place like this. So this group remains intact and the reaction takes place. CO gives CON3. So here you will find that this acyclic diene system is complexed with this tricarbonyl iron to give acyclic diene tricarbonyl iron complex, and this is useful for producing valuable intermediate for the asymmetric synthesis of polyenic products, natural products and structural analogues. So this is polyenic natural product. So the diene system is temporarily protected by using this functional group protecting compound, which allows the reaction to occur at remote places away from this group. So without disturbing any of these diene system, we will get the product as per our desire. Another interesting fact about this is that the reactivity of the molecule can be modified or changed completely as against the uncomplexed compounds. So this is the importance of organoiron compounds. Now, the next is planar chirality. Planar chirality. So this is planar chirality is shown by organometallic compounds such as ferrocene. For example, ferrocene. So these ferrocene compounds are sandwiched, means metal is sandwiched between the dienes such as cyclobutadiene, and because of this it gives and makes a very significant contribution to the area of asymmetric catalysis. So this helps in the asymmetric catalysis. So this is the importance of planar chirality shown by the ferrocene. So unlike other forms of chirality, ferrocene does not give a racemization. So there is no racemization when we use ferrocene, because in such case the twisting or rotation shows the bond breaking. So without bond breaking, the racemization of the molecule is not possible. There are also derivatives of ferrocene and other few stable metallocenes and half sandwich complexes, which are also showing or known for their planar chirality. So we will show some examples like this. Me2M, CH2, PPH2, so Fe, so this Fe is centered between these two dynes, and this is S variety, or it is called PS. So after taking its mirror image, we get the structure like this: PPH2, CH2, Young, Me2. So this is S for, this is R for, or it is also called PR. Then another important structures are also like this. So this is called JOSIPHOS. So there are 1 to 9 examples in this JOSIPHOS. Another is called cobalt or Thazoline. Parallel cycles. Parallel cycles. So these are various ferrocene or similar enriched compounds which are showing this planar chirality. Many organic species which are highly unstable and often cited as intermediates can be stabilized by complex formation or bonding with metal. This provides valuable evidence for their intermediates. These highly unstable compounds which when form complexes with the metals gives intermediates which are stabilized, means after stabilization they are useful for giving evidence for their mechanism, especially for the formation of intermediates. Their mechanism and formation of intermediates are very important, and this is given by or explained with suitable example such as cyclobutadiene and benzene. So this cyclobutadiene and benzene, cyclobutadiene and benzene are stabilized by complex formation, but these are highly unstable and but stabilized by complex formation. We will show this with the example. So this forms complex with tantalum. So this is benzene, which is stabilized by complex formation. Another example is so here cyclobutadiene is stabilized and this is benzene stabilized by complex formation. The interest of organic chemist lies in the organometallic chemistry, which is found to be dominated because of the usefulness and diversity shown by these compounds, especially in homogeneous catalysts or catalysis. Organic chemists also explore the synthesis of new metallic organometallic compounds, their stability and structural aspects, and then finally they determine potential applications of these compounds in the field of catalysis. In addition to this, but in the minor extent, organometallic compounds also find applications in extent, such as the organometallic compounds can be used in devices, production of devices, and they are also used in as a carrier gas in chemical vapor deposition method, where the complexed metal is allowed to form a very monoatomic thin layer, which is used in electronic devices or in any other applications. Another application is it can be used, organometallic compounds can be used as polymers and metal precursors. So these are here some of these important applications of organometallic reagents. Organometallic compounds as additives. So these compounds can be used as additives so that the properties of the existing liquids are modified. So this modification becomes useful for the application of some liquids or gases for a specific purpose. So the application as bulk additives shows modification of the properties, and it helps to choose these compounds for or any other substances like gasoline or any other fuel like that. So they can be used for any specific purpose without causing any damage to the environment or human beings. So the catalysts are found useful in synthetic or in industrial purpose, industrial manufacture of many other organic compounds, where the specificity is highly required. So in such case, we can see some of these organometallic compounds as additives. So for example, the one is PB. So it gives tetraethyllead, that is TEL, tetraethyllead. Similarly, another is that is methyl cyclopentadiene, Mn. So this methyl cyclopentadiene is complex with Mn, tricarbonyl Mn, and it is called methyl cyclopentadiene. Methyl cyclopentadiene, manganese tricarbonyl. Manganese tricarbonyl. It is called MMT, shortly represented as MMT. Another is cyclopentadiene iron cyclopentadiene. So this we know very well. Shortly it is called FC, that is ferrocene. And one more compound is tin in the form of oxide. So this is butyl group. This is tributylene oxide. Tributylene oxide. Tin. It is called TBT. Tributylene oxide. Or in short, it is called this tributylene oxide. So these are some of the additives which we have shown here. Now we have to see the applications of these additives and their importance. So we will take one by one. So first is tetraethyllead. Tetraethyllead. So it was discovered by Middle in 1921, and it was found to be viscous. Viscous, colorless liquid, colorless liquid, which acts as effective anti-knocking agent. Anti-knocking agent. Because of this, here during combustion, the lead particles and lead oxide Pb and PbO2, so these particles are formed, and which makes the combustion smooth and slow. So this helps in the smooth functioning of this combustion and slow also, and because of this the efficiency of fuel is improved, and because of this the cost of vehicle is also made very controlled. So this prevents, means when this tetraethyllead is added to gasoline, this is added to gasoline, and because of this it helps to prevent the knocking, and also it takes place with higher octane number. If we see the preparation of this tetraethyllead, so Pb plus 4Na plus 4CH3 CH2Cl gives Pb CH2 CH34 plus 4 NaCl. So this is what we say tetraethyllead. Anti-knocking properties are compared with variety of additives. This number of additives were studied, like this tetraethyllead, and their relative effectiveness as anti-knocking agent is obtained, and this data shows that the aniline is considered to be a reference which is said to have the relative effectiveness as 1. So compared to this, ethanol gets the anti-knocking value 0.1, dimethyl cadmium 1.2, tetraethyl 4, then diethyl selenide 7, diethyl telluride 27, nickel tetracarbonyl 35, iron pentacarbonyl 50, tetraphenyllead 73, and tetraethyllead 118. So this has highest value. Tetraethyllead has 118 value, means it shows that it is the superior additive for gasoline. So it shows that the combustion becomes slow and highly smooth. So it helps to save the fuel cost and also improves the combustion. The leaded gasoline is found to show the emission of harmful chemicals, that is poisonous, bromides and chlorides of lead. So during the combustion of gasoline, when it is added with tetraethyllead, shows the emission of these highly poisonous compounds. So these compounds are released into the atmosphere during combustion through the exhaust of engines. As a result, the atmosphere is contaminated, and these compounds are highly hazardous to the human being. And these lead also contaminates or poisons the catalytic converter, and as a result of this means being the hazardous nature of these tetraethyllead, it was eliminated from the usage as the additive in gasoline. But this is not done instantly. In India, this was phased out, means the use of tetraethyllead in gasoline or petrol is phased out from 1994 to or by 2000. So this is about our tetraethyllead. Next is MMT, that is methyl cyclopentadiene. Methyl cyclopentadienyl. Cyclopentadienyl. Manganese. Manganese tricarbonyl. MMT. This MMT is manufactured by Ethyl Corporation. This is manufactured by Ethyl Corporation. Ethyl Corporation. And it is sold under the trade names as High-Tech 3000 and EK 33X. It is used as anti-knocking agent. This has anti-knocking properties. Anti-knocking properties. Properties are similar to tetraethyllead. Its melting point is -1 degree centigrade, and if we compare the quantity required in gasoline, it is much less than that is required for tetraethyllead. In tetraethyllead is required in larger quantities, whereas this is required in smaller quantities as anti-knocking agent. In addition to this, it is found that this MMT is highly toxic to humans. Its exposure causes hazardous effects, and it is called manganism. So this manganism means the disease, means the ill effects of this hazardous illness are similar to the Parkinson's disease, and because of this is not found to be used in the additives in gasoline or fuels. Then next is ferrocene. So ferrocene found to be the most efficient additive in gasoline, and it does not have any hazardous effects to human being or the environment. In addition to anti-knocking properties, the fuel additives used here are to reduce the soot emissions, means carbon emissions. So the purpose of use of ferrocene or any other additive is to reduce the soot formation during the emissions. Ferrocene has well-known soot suppressing properties. Ferrocene is readily soluble in liquid fuels and it is air stable. It is non-toxic as we have seen earlier, and it is usually heat stable also. Means there is no modification in the properties of the ferrocene as well as the fuel. Means fuel properties are modified with respect to the combustion. Ferrocene reduces the formation of carbonaceous matter, that is soot, during combustion, and after combustion the iron oxide which is formed during combustion acts as a catalyst to burn out the complete carbon formed during combustion. So the soot formation is prevented completely. And this combustion of iron oxide means combustion of carbon using this catalyst iron takes place in oxygen rich areas present in the combustion system. Ferrocene is the safest additive for human being or our environment, and as we have seen earlier, it does not cause any harmful effects in the environment. If it is used as a catalyst in rocket propellant, it can improve the combustion by 1 to 4 times. And ferrocene is used as a networking agent in the rocket propellant. It shows better effects and saves the energy and fuel also. The temperature of the exhaust is also reduced, and it shows the reduction in infrared gas. When it is used in different oils such as diesel oil, heavy oil, light oil, it can eliminate the smoke completely, save energy as well as reduce the air pollution. So this is the best additive that can be used as anti-knocking agent and also prevents the environment from being polluted. And next one is bis-tributylene. Bis-tributylene. So this is shortly called TBT. So this tributylene is specially applicable in the marine business. When the ships are working in the ocean, then the fuel cost plays very important role in reduction of the cost of transportation. So the fouling is important hazard for affecting the fuel cost of the ships. The fouling is found on the surface of ships which are submerged. So this is taking place because of the creatures, small creatures and the other moving creatures. So fouling is nothing but, marine fouling is nothing but the attachment of crustaceans and other movable creatures, and presence of, means formation of the layer on the surface of submerged ship affects the cost of transportation. Means cost of fuel is quantity of fuel required for shipping process is increased because more fuel is required when there is fouling on the surface of the submerged ship. For example, 5% fouling can cause the 17% cost rise, can cause 17% rise in the cost of fuel. Whereas when there is 1 mm thick fouling on the surface of submerged part, it reduces the fuel speed by 15%. Means ultimately it affects the fuel cost, means consumption of more and more fuel. So TBT is most effective fouling agent. So it can reduce the fuel cost by removing the fouling for 5 years. Next one is organometallic compounds as catalysts. Organometallic compounds, or we can say as catalysts. Catalysis. So traditionally, industrial processes choose heterogeneous catalysis, where the reactants are in one phase and catalyst is in another phase. Like the reactants are in liquid phase, catalyst is in solid phase, or reactants are in gaseous phase, catalyst is in the solid phase. So this is heterogeneous catalysis, but this is traditional method which is used on industrial scale manufacture of chemicals. There is alternate method, that is homogeneous catalysis. There the reactants and catalysts are working or used in the same phase, and it is found that the homogeneous catalysis is best applicable in many reactions where the industrial application is used. Most of the laboratories are engaged in using the homogeneous catalysis, but it leads to tedious. Means when we use the homogeneous catalysis, after completing the reaction, the resulting product contains impurities also, and this removal of impurities from the same phase becomes a tedious process. So this is one of the important drawback of homogeneous catalysis. Pharmaceutical products have been contaminated by this catalyst. What is the cost of production of such chemicals is also increasing. Now if we see the use of these catalysts, the reaction and industry. So if we see the first catalyst, CO twice, CO8, this is cobalt and this is carbon monoxide. So it is used for the reaction of hydroformylation. And industry associated is chemically, that means BASF. Another rhodium catalyst is used as RH CO twice I2 minus. This is used in methyl carbonylation, methanol carbonylation. It is usually Monsanto. Industry is Monsanto. Third catalyst is also rhodium, RH, HRH, CO, PPH3, triphenyl phosphine twice. It is also used in hydroformylation. The industry is Union Carbide. Johnson method. Johnson method. Another catalyst is nickel. NiCO, then PH2, PCl2, COO. It is used in ethylene oligomerization. Ethylene oligomerization. The industry associated with Shell, shop process. Then next catalyst is zircon, which is used as CP2. It is ethylene polymerization. It is used in ethylene polymerization. The industry associated with is Dow and Exxon. Dow and Exxon. Next catalyst is also rhodium, RH, Bina, Binam, COD, ClO4. It is used in the synthesis of L-methanol. L-methanol synthesis. The industry is Takasau International Corporation. Another catalyst is iridium. CO twice I2 minus. This is used for methanol carbonylation. Methanol carbonylation. The industry associated is BP, Cativa, process. So this is about the discussion of importance of various organometallic compounds as reagents, additives and catalysts. So we will stop our discussion here and we will see the next point in the next lecture. So till then, goodbye, see you next time. So if not subscribed to this channel, please do subscribe and also do not forget to press the like button. So thank you very much.